Hello and welcome to the construction management presentation on construction safety, specifically safe excavation and trenching. In this presentation, I'll look briefly at the workplace health and safety legislation that drives excavation compliance requirements in South Australia. We'll look at real-life scenario of when something does go wrong. I'll explain what the Excavation Code of Practice requires and show a brief animation I developed with SafeWork SA, which covers the fundamental requirements for safe excavation and trenching. I'll then describe typical approaches of compliance to achieve safe workplaces, workers, and systems of work. This will lead us into the legal requirement for safe work method statements for high-risk construction work. I'll also provide some examples of where we can choose higher levels of prevention from the hierarchy of controls and just who is watching over our shoulder to make sure we're compliant with excavation and trenching safety requirements. We have a Workplace Health and Safety Act, which also references a number of other pieces of legislation. It is supported by the regulations and nominated standards which are mandated by law. There are numerous other Australian standards which provide good practice to be followed. Industry and regulators also have standards and guidance on appropriate practices to be applied. The object of the Act is to provide a nationally consistent framework for the health and safety of workers and workplaces. The supporting regulations are provided to protect the health, safety and welfare of workers and others, defining the responsibilities for elimination or minimisation of risk. In the regulations, there are identified 18 construction work activities classified as high risk. High risk construction work is required to have a safe work method statement. Safe Work Method Statements, or SWMS, is a team risk assessment which documents the work task, high-risk construction work activities to be undertaken, hazards, control measures, initial and residual risk ratings, and persons responsible for SWMS control, implementation, and review. So when we've got a high-risk construction work activity, and in this example, let's say a trench deeper than 1.5 metres. There are a number of other high-risk construction work activities that may need to be included in a SWMS. So if we had section G there, in or near a shaft or trench with an excavated depth greater than 1.5 metres or a tunnel, we may need to consider the application of controls for high-risk construction work activities such as risk of falling more than 3 metres, being in a confined space, on or near pressurised gas distribution mains or piping, on or near energised electrical installations or services, in an area that may have a contaminated or flammable atmosphere, on or in and adjacent to road, rail, shipping lane or other traffic corridor that is in use by traffic other than pedestrians, and in an area at a workplace in which there is any movement of powered mobile plant. Noteworthy that any construction project that has a value equal or greater than $450,000 in value requires a workplace health and safety management plan to be developed and in place. So what could go wrong?
A man has survived the horror of being partially buried alive in an industrial accident at Dry Creek. A trench collapsed, pinning him under a wall of dirt and mud.
Finally freed from the earth. At around 12:20, the man was digging in the 2-metre deep trench for the Gawler rail electrification when disaster struck.
It's about 2 metres deep and it's caved in on him. So it buried him from his legs. And so his legs were actually in the squatting position, went covered in the dirt.
It took the MFS, SES, ambulance and police 40 minutes to free the distressed contractor who was trapped on his knees.
We have people on scene currently digging someone out.
We started digging, but obviously trying not to put any more soil in there, so we had to put boards around, wait till a heavy rescue pod turned up for that.
Rescue crews who were in the hole acutely conscious further collapse could prove fatal.
There was a danger that we had to watch out for our crews, that they weren't also trapped there, but we're also working time critical to get him out for the ambulance crew.
His distressed workmates who witnessed the accident helping with the rescue. Fortunately, a vacuum truck was on site to extract excess water. The man became increasingly panicked and anxious during the ordeal as the weight of the mud and the soil compressed on his chest.
There was no stopping, we had to move him and we just had to be prepared for any symptoms of crush injury.
He was taken to the RAH in a stable condition. Workplace SA arrived on scene to start the investigation. Jodie Oddie for 10 News First.
So in terms of what could go wrong, the Code of Practice for excavation provides some specific excavation hazards, which may include falling into an excavation, being struck by a falling object while working in an excavation, ground collapse involving the fall or dislodgement of earth or rock, as we saw in the video, engulfment by material or water, instability of adjoining structures caused by the excavation, underground or overhead services including gas, water, sewage, telecommunications, electricity, chemicals or refrigerant in pipes or lines, exposure to an airborne contaminant and other factors reducing oxygen levels, and asbestos disturbance. My employer, SGP Civil, developed an animation aimed at identifying the key requirements for excavation and trenching compliance. The construction management student employed with us watched the animation and responded, "If uni was like this, I could learn so much more." The animation is now available on the Safe Work SA website.
The nature of excavations will affect the excavation method and a safe system of work. Careful consideration should be given to health and safety issues when planning the work. Trench work can be dangerous for yourself and others around you. What is a trench? Longer than the width, a narrow man-made excavation made below the surface of the ground. In general, the depth is greater than the width. A trench greater than 1.5 metres deep is classed as high-risk construction work and requires a SWIMS. Any person engaging, directing or influencing a worker has a duty of care under the Act. Before you dig. Before breaking ground, you are required to contact Before You Dig Australia and other potential asset owners, ensuring you obtain current underground service information. Secure the work area from unauthorised access and control all on-site access. Identify any exclusion zones and obtain any required power network permits. Digging the trench. For benched trenches, base the sequence of excavation on the bench width and machinery track width. An angle of repose of 45 degrees should not be exceeded unless certified by an engineer. Spoil placement must be at least 1 metre outside of the zone of influence, mitigating risk of collapse and flooding. Entering a trench. Before entering a trench, the sides must be shored, shielded or boxed, benched or battered. Workers must stay within these controlled areas. Access to a trench without these controls requires a geotechnical engineer's written advice. Access to the trench must be provided by ladders no greater than 9 metres apart. Arrangements for the emergency extraction of incapacitated workers must also be in place. The trench must also be inspected frequently, ensuring all controls and conditions are suitable for the work to occur. Anyone accessing the trench must also review and sign a SWIMS, identifying the high-risk construction work controls. When ventilation controls are inadequate, confined space requirements may also apply. Mobile plant and vehicles. Traffic management and exclusion zones are required on site when trenching. All shoring needs to be engineered to meet load requirements, and the zone of influence secured using fencing or wheel stoppers. Remember, it's your responsibility to ensure correct processes and procedures are completed before breaking ground. Digging a trench greater than 1.5 metres is considered a high-risk construction site, and no one should be working alone. Use a permit system and ensure an emergency response plan is in place, which is a legislative requirement and should be tested periodically. For more information, head to the Safe Work SA website.
We've briefly covered the legislation and code of practice. Now we need to put those requirements into action. We need a comprehensive WHS management plan for projects over $450,000. We need a work method for setting up and performing the work. We need a SWIMS to cover all the high-risk construction work activities which could seriously harm or kill someone. We need geotechnical report for the area being excavated. We'll then need to use our management system tools like permits, rescue plans and inspections to ensure a safe system of work. When do we need a SWIMS? Under the regulations, SWIMS are required for the 18 high-risk construction work activities. A SWIMS is not required for work of a minor nature, and the Code of Practice for Construction Work outlines the specific requirements for a SWIMS. The 18 high-risk construction work activities are ones that involve a person falling more than 3 metres, work carried out on telecommunication tower, demolition of a structure that's load-bearing, work that involves the disturbance of asbestos, temporary support, confined space, a shaft or trench greater than 1.5 metres in depth or a tunnel, use of explosives, working near pressurised gas distribution mains or piping, chemicals, fuel or refrigerant lines, energised electrical installation or services, contaminated or flammable atmospheres, chilled up or precast concrete, a traffic corridor, movement of powered mobile plant, artificial extremes of temperature, work carried out on or near water, and work involving diving. The front page of a SWIMS has a number of mandatory requirements, including the indicated 18 high-risk construction work activities. It's important to keep the scope of the SWIMS manageable, otherwise the SWIMS itself becomes too big for anyone to absorb, and remember the controls which prevent serious harm or fatality. Here we've got an example from a trench excavation, specifically defining a 3-metre excavation, tying in some stormwater piping. It identifies the applicable high-risk construction work activities applicable to the scope. It identifies a number of other key characteristics around the work that is being performed under the SWIMS, and it nominates a particular person as being responsible for monitoring and ensuring that all of the controls within the SWIMS are being complied with. This person is subject to offences and penalties under the Act. As we can see there, depending on the level of the offence, determines the amount of any fines, and indeed in the case of gross negligence or reckless conduct, prison time. Also noteworthy that it's not a requirement that someone gets hurt. It can be a near miss scenario set up where someone could have been seriously hurt or killed. Just a brief example which shows one section what the high-risk construction work activity is. In this case, our company, like many others, utilises 2 metres as the the demarcation for a fall, not 3 metres, because South Australia is the only state that has 3 metres, everyone else has 2. You then list the number of different hazards and risks that apply, so it would be more than just the one that's identified here. Good practice to identify what the initial risk rating is without any controls in place. Then put into place all the controls that are relevant to preventing serious harm or fatality, and make sure that you identify the level of hierarchy of control of those controls, and then a subsequent residual risk rating to determine if you've adequately controlled those risks to an acceptable level. Finally, it's got the people who are responsible for carrying out those controls when the work is being undertaken. At the end of the swims, everyone involved in the work must sign on to the swims in order to then do the work. So that happens before the work commences. Other important rules around safe work method statements are all workers undertaking high-risk construction work activities must be consulted on the site-specific hazards and risks associated with the high-risk construction work, including the control measures. The swims must be kept and be available for inspection until the high-risk construction work to which the swims relates is completed. If the generic swims is revised, all versions shall be kept. If a notifiable incident occurs in relation to the high-risk construction work, the swims must be kept for at least 2 years from the date of the notifiable incident. If the control measures listed are not effective, then work must stop and the swims must be revised following consultation with workers. Workers must sign on to the swims acknowledging the control measures listed in the swims are not negotiable. The swims must be revised to include the outcome of the consultation with the workers. And it's a requirement of the law that swims must be reviewed. Here we have an example of a swims review and approval, identifying exactly the project and identity of the swims, together with a number of typical requirements that we need to make sure that we have met in developing the swims. Finally, an acknowledgement of approval with modifications, and there's a section for that, the required modifications before work can proceed, or if indeed the swims is not approved. Next step is we need a permit to do the excavation, and the permit is the gatekeeper to compliance. Without it, you can't begin the work. So we need to identify what all the services are, and I'm sure you've all heard of Before You Dig Australia. So that identifies all above and in-ground services, also getting a geotechnical report for previous ground disturbances so that you know what it is that you're going to be excavating. The permit typically provides a list of preparations, a checklist, if you will, to make sure that all of the things that need to happen occur. So you've got a swims, you pothole and non-destructively excavate to physically identify all of the services which were identified in the Before You Dig Australia information. It's got around the boundaries and physical markings so that we know exactly where things are located. Arrangements for rescue should any events occur so that people can be safely and reasonably extracted under all of the different scenarios of what could possibly go wrong. Have we got all of our shoring and shielding in place where we've got someone going into the trench to ensure that they're not at risk? Are we generating dust with silica containing substances that need to be dealt with? And some companies choose to run their own dust work permit system as well as another gatekeeper to ensure compliance. Is the area a confined space? Have we designed the trench in a way that eliminates the need for shoring and shielding? Have we got spotters in place? Are they trained and competent? Have we established what exclusion zones are going to be used during the digging phases and for spotters and other people? And have we figured out where the overhead power lines and services are and how we're going to have exclusion zone from them? So for our overhead power lines, there are defined requirements depending on the level of voltage involved. For underground services, similarly, SA Power Networks provides a set of requirements to be followed, again based on the voltage of the cable. There's a number of requirements around the perimeter of the work site. So the perimeter must be appropriately fenced, must have warning and information signage. Excavations themselves need barriers and warning signs to prevent people falling into the excavation. Trench plates and covers can be used when no work is occurring to reduce fencing and restrictions. People must not step over a trench. Where people need to cross a trench, a crossover walkway, which is compliant with Australian rules for the height and gaps of railing, etc., and for kick plates are all present to prevent a fall into the trench. In terms of general non-compliance, we've got here some examples where the shielding needs to be at least 300 millimetres above the edge of the excavation. And there seems to be a lack of fall protection barriers to prevent people falling into the excavation. Another couple of examples, one where there is a barrier fence, but it is not strong enough to restrain anyone from falling into the trench, and there is no signage to warn that it's a deep excavation. In the other photo, we can see some very unlucky workers working in what appears to be a very sandy soil condition with completely inadequate shoring, which should have far more extensive protection for the workers and also a means of access and egress every 9 metres by way of a ladder, ramp or other alternative. Here we've got some guys who've got it figured out. They've got a nice little trench less than 1.5 metres, except that their spoil is closer than 1 metre, and we can see from the code of practice diagram on the right hand side that the measured depth of the trench is from the top of the spoil to the bottom of the trench, not from the level of this guy's hip. So this is a trench deeper than 1.5 metres. There's another number of other tools that companies have in their management system arsenal. A couple of examples here is excavation inspection checklist. The checklist is a requirement under law. It stipulates that it's routinely done, but doesn't specify a frequency. We as a business do excavation inspections every day and every shift that people are going to be getting into that particular excavation. We also developed, after many service strikes, a job sheet for use at the start of each shift for our excavation teams when they go out onto the site to make sure that all of the services are marked, the conditions haven't changed, that they're confident and set up correctly to have a successful excavation session that day. Some other requirements around raising the bar. So do we want good practice, better, or best practice? So some of the examples of that, many companies don't use the greater than 1.5 metre deep trench rules. They apply all of the requirements for excavation and trenching where the trench is greater than 1 metre in depth. Other companies have mobile plant with smart cameras systems fitted which detect people movement within their area of movement and shut the plant down. Other examples of better and best practice is how to set up your exclusion zones. So we typically have a spotter. In the first one, we've got him administratively placed outside the swing arc of the excavator. Then we've applied some engineering solutions and actually put a fence to stop the spotter from inadvertently, or any other people inadvertently, going into the exclusion zone. And then higher up again in the hierarchy of controls, here we've completely isolated the machine and anyone else in the vicinity. So who checks on us when we're doing excavation and trenching to make sure that we're compliant? So here are some examples. Civil construction companies are generally ISO 45001 Safety Management System certified, so they are externally audited by companies on 6 or 12 monthly cycles to ensure that they are following all the requirements they need to for a safety management system. The Federal Safety Commission accredits a number of companies, and they also perform inspections and audits. The Department of Infrastructure and Transport in South Australia accredits companies, and also on any infrastructure works will perform audits and inspections at their discretion to ensure compliance with their higher level benchmark of requirements. There are also other regulators such as Safe Work SA who look after health, safety and well-being, the Office of the Technical Regulator who looks after electrical, gas and plumbing compliance. There's also your clients who are going to make sure that they're not being exposed to unacceptable risks and that our business is operating in a way that complies with their needs. And we have our own internal programs in terms of audits, inspections and so forth to ensure compliance with planned arrangements. Thank you for your attention. If you would like further information, you can go to the Safe Work SA page, search for SWIMS, and that page will show you a list of the 18 high-risk construction work activities, provide you with a sample SWIMS template, a self-assessment checklist to make sure that your SWIMS is adequate. It'll provide you with an example SWIMS from the building industry. There's also a link to an interactive tool on developing safe work method statements and a link to the model code of practice for construction work. Thank you.